Thank you, thank you. So I've met most of you before. If not, I've been out at the table all day, so please stop by even after, and you can come get to know me, so Cliff Worth, and there's a few other people from Elastic here. So we're always willing to answer questions, and we're here for you guys. Today we're going to go over a little bit of Linux and Elastic, and specifically we're going to be going over extended Berkeley packet filter and how that is helping Elastic security and how you can actually see more inside of your Linux distros in your enterprise when collecting with the SIEM. So here's a little bit about me. I'm a consulting architect for Elastic on the federal services side. 14 years in the Army, 8 of it doing incident responses, cybersecurity, mostly focused on the ICS SCADA side. I'm a data scientist by trade. I really enjoy Python, RStudio. I've recently got into Apache Spark. Been doing different things in the data science area. Here you can follow me on Twitter. You won't see much there except, non-controversial opinions about, Dallas Cowboys are the best team in the NFL, MMA is the best sport, things like that nature. And then, of course, here's a link to our company. All right, so eBPF. Before I get into what extended Berkeley packet filter is, I wanted to ask if anybody else here knows what Berkeley packet filter is. I saw your hand first. Purple shirt, I think. Yep.
It is a way to look at the packets by going through the headers and pulling out the data that you're looking for. And you can get pretty low grade into it as necessary, going by like what byte in the header and the number of bits you're looking for.
Yeah, exactly. Yeah. So you can obviously hand you one of those. So one of the best parts about Berkeley packet filter is what it does is it's a kernel level program that will essentially sift through different packets as you absorb them on the network very quickly because it's at the kernel level. Well, what we have today is called the extended Berkeley packet filter. Not really related at all. eBPF is written in a completely different code, has nothing to do with BPF whatsoever. Outside of BPF, you have to call eBPF with a syscall from Berkeley packet filter. So it's all of the codes that you would run are written in C. They are loaded with different syscalls. You'll see right here on this slide is just some technical information about how eBPF can be called by BPF. So that's essentially what this slide is just to kind of walk you through it. Different ways to call different compiled C language. You can write your own. There's a community of there's distros all over the community, both in Elastic and outside of Elastic that are using eBPF as well. So you'll also notice that my name is not Tammy. Tammy could not make it because of Hurricane Ian. So occasionally, I'm going to reach over here and I'm going to just mark out where I am. I found out 24 hours ago I was giving this brief, so give me a little bit of a break here. Okay, so visibility through eBPF. Quick little poll here. Who has done an incident response? And inside of an incident response, who has encountered a Linux box? Okay, so not many of you. What are some of the different logs and things that you're going to want to grab? Just give me one.
Well, you're going to go to syslog and look at the security log.
Yeah, for sure, but specific to Linux. Audit logs is what I was looking for. So traditionally with Linux, before EDRs and stuff started making their breakthrough into the Linux distros, you had to go through audit logs. You had to go and collect different data sets with, like, just running ps-tac-elf, tracing those PIDs to PPIDs, and it was just horrible. It was awful. So what does eBPF do? What does it actually do? So eBPF is a tool that actually hooks into a process as it's running inside of the Linux kernel. So it's compiled in C, and one of the benefits that it does is as the process is actually being executed, it is caught in the stream of the execution. It is not caught afterwards. So typically with like audit D or any other kind of logging, the event happens and then it's logged by the OS or some kind of third-party application logging, whatever that may be. With eBPF, as it's occurring, it is being logged through a stream in the hook. And we're going to go over that in just a little bit, try to keep it lower level because that's where my knowledge base is on it. So hook points, yes, so this is what we were talking about. You can see as different syscalls inside of the kernel are executed, you can actually pass eBPF programs to it. And again, these can be different things inside of Linux. There are a ton of companies that are starting to get into external BPF or extended BPF programming, and there's a ton of different ways to actually use it. So what we're going to get into here in just a few slides is I'm going to show you how Elastic is using it and some of the benefits and pros that I've seen, that I've experienced on an actual incident response. So what do I get with this? So you're going to see here in a few slides that the system call data and is combined with packet information. So what do I mean by that? So you're going to see audit D data, process ID data, and it's going to be in human readable format. Another problem that you've also seen in Linux is sometimes it has an issue with metadata. Sometimes you will see the aggregation of metrics is a kind of a problem. So these are kind of some of the solutions that you're going to get as you implement this inside of Elastic. So one of the things we didn't talk about is performance. So with eBPF, as you compile it in C and you run it, there's a couple of things that'll happen. Either A, it will run and it will do what you told it to, or B, it will error out and break. However, it does not break your system. It doesn't run in a part of memory that will actually kill your system. So one of the benefits is that it's safe. As you are running it, it will hook into whatever process that you called and the kernel, and it will actually just either fail or succeed. So that's kind of what we get with the reliability and compatibility issues. So yeah, MITRE ATT&CK mapping. Here is where it starts to get a little bit confusing. So there is a couple of engineers known as Jed Salazar and Natalia Rika Ivanko. Both of these guys have mapped out where eBPF can solve these initial techniques. You'll see that a lot of different organizations, including Mandiant before, in the brief before, they use the golden standard that is MITRE ATT&CK matrix to map out different attacks. And when you're mapping out how you're going to do your security operations, including SIEM, what you want to utilize is some kind of methodology to capture as much of what the adversary actually does on a network. So whatever it may be, your SIEMs, your EDRs, whatever kind of solutions you're trying to build your defense in depth, you always want to kind of use the MITRE ATT&CK matrix or some other kind of methodology to map out and get as much of this as possible. Well, what we can do with this eBPF is actually map most of those MITRE ATT&CK frameworks inside of the Linux distros. And that's what this is breaking out, and that's what those two authors have done for us. And again, if you, at the end of this, if you need their names or the book, I'm more than welcome to give it to you at the tables. Okay, so audit D. We've already talked about it. Anybody that has been through it knows that audit D is a pain in the butt. I mean, just look at it, right? You can only grep so much So this can be really, really difficult to look at. It can be really, really difficult to process the data. What of the metadata here is actually usable? Which of the metadata is key? These are things that just make it really, really difficult to process this. And I'm going to show you here in a second why using extended Berkeley packet filter is going to be usable or more useful than this right here. So this is just your straight output of these logs. And again, if you've ever done this, it's incredibly difficult to process. Okay, so this is where I can start to brief you a little bit on what we're using inside of the Elastic Stack. So what we have here is a capture of some of the processes and the PPIDs and the metadata associated with PID and PPID inside of your Elastic distro. So what makes this usable? What makes this better, right? So one, it's in a GUI format. You have different, you have the metadata there, you have alerts that you can create inside of the Elastic Stack as it relates to this alert, to this event. And that can be for anything. Right, what you see right here is just somebody ran an LS that created its own entry into a process and then was listed inside of Elastic Stack. Again, metadata that doesn't require a PhD. Metadata can sometimes, depending on what it is that you're using, can be very, very useful or completely useless. So it just depends on what your organization is using it for. But essentially right here, I just have a quick printout to show you the host name, the ID, IP, things of that nature. These are all things that you can configure inside of your extended Berkeley packet filter. Here is a session view. So this is an investigative tool that we actually have right now inside of Elastic Stack. So this will break down essentially all those different logs that we were talking about inside of Linux, and it will break it down into a streamlined format for you to show you exactly what objectives an attacker or maybe just a bad user did on an endpoint. So you can see here, by just this example, we saw that somebody, and this is an alert that we actually created, somebody created a hidden file and directory. If you click on that, it will actually give you in the metadata below how they created it, what commands were used to create it, and essentially what processes, what users, anything of that nature. So before, Linux doesn't really do a good job. You're not bringing up process hacker or a process tree on Linux, right? It ain't happening. With this, you can actually do that inside of the Elastic security stack. Human readable process, yes.
How are you guys getting that information into the Elastic Stack? Are you using some type of beads, an agent is moving that information back?
So it depends on what your organization wants and how you're going to collect that data. So you can use, we are actually in the process of developing the Elastic security agent that will actually collect some of this data for you. You could use a beats by all means if you want to. It just depends on how you want to configure it, whether you want to do beats or an agentless, like EDR solution. So it's up to you, really. Yeah.
Follow up on that same question. Is the capability that you just showed something that is built in or something that we would add? Because most of the capabilities are things that we typically add.
Right. So those right now, for the Elastic security agent are coming by default. However, there are additional things that I'm going to point out to you at the end. We have a GitHub. This project will be open source for the foreseeable future. And there are many, many use cases because it's going to depend on what kind of data set you have. But people are already starting to write different C code because that's hard to just kind of do unless you have a background in it. So some of this is functionality that's already built into the security agent, some of it's not. So runtime security is your security camera. So what we're getting at here is this is a little meme to kind of point out that Elastic considers this a runtime security issue. Because the event is happening in stream, we are considering that a runtime security thing. So as the event is occurring, we are ingesting that data and making it available to the analysts. So in conclusion, audit and compliance logs have come a long way. eBPF is something that we are using to develop future capabilities inside of our Elastic instances because of the power it has with the endpoint Linux distros. So one of the things I kind of didn't really discuss with you guys is right now, there's only a couple of capabilities inside of Linux that give you the capacity to look at this kind of data set, right? So dtrace was one, that only works with Mac OSs and some Solaris. I don't think anybody in here is rocking a Solaris machine right now. There's a few others like ptrace, things of that nature, but there was nothing that encompassed the entire Linux distro that kind of gave this ability to look at a process, right? So if I'm an attacker and I inject a malicious something into a process inside of a Linux box, how is that going to get seen? How is that going to get viewed by the analyst, right? Outside of doing a memory capture and doing a hash of that individual process, how are we ever going to see that this malicious process was violated? And so that's essentially what the power of this does is in real time, it will actually create, and I'll go back here real quick. Right here, it will actually create a fork of that process. So when I inject something malicious into process, whatever that is, host name right there, it is going to absolutely create a fork, and I will see when it changed, what the user did, and what the command line entry was for that. And this is pretty cool for Linux, because before, like I said, none of this really exists natively to Linux. Another thing is that we talked about eBPF is that it doesn't utilize a lot of memory. It doesn't, if it fails, it fails safe, right? It doesn't fail open. It doesn't cause any outlying effects on your system. So there's no big deal. There's really no effect to otherwise your actual Linux box and the business processes you have for that Linux box. So you don't actually incur a lot of performance issues. Again, thank you for bearing with me as I struggled through that presentation. Again, my name is not Tammy, it's Mikey. If you have any questions, please, by all means, go ahead and ask them. And I wanted to thank B-Sides for letting us continue to give this brief.
I do have one question.
Yes.
So you drop it on a Linux box, right? Say I got a Bluetooth home, right? I'll drop it on there to monitor home things. So to his point, like how am I going to be able to view it on my system? Is there going to be another service that's ready to look at that information? Or will I have to stand at the Elasticsearch to view that information?
So eBPF is actually written into a lot of different tools. You by no means have to just go out and get Elastic to do it. Yeah. However, I work with Elastic, so please download it. But by all means, you can use any tool to use eBPF. It is a industry-wide tool, and it is an open source program. I believe we own the company that created eBPF, but right now, from what I understand, it's going to remain an open source tool for a while. Yes?
So, just to clarify, we have Elastic agents.
Yes.
And then we have what you just said, the endpoint security, or, thank you. We have Elastic agent, and then I think you mentioned the word Elastic endpoint security. Can you clarify licensing and the functionality you're talking about here? How does that fit into Elastic agent, and what does that all look like?
For sure, absolutely. So Elastic offers, primarily right now, for a security tool, we actually offer what's called Endgame. So Elastic purchased Endgame. That is our traditional EDR. That is what we are offering as an EDR, fully functional out of the box right now. We are in development of an Elastic agent, or Elastic security agent, that will function with the Elastic stack so that it's kind of like all in one, if that makes sense. But that's kind of what we're getting at. I believe that has started to be offered. Is the security been offered? I'd have to check and see if we're actually offering that out wide to the community, but I know it's in development at the moment.
So what you're referring to here is going to eventually go into Elastic agents?
Yes.
Okay.
that is how we're going to use it. And it'll, like I said, it'll be by default that some of these tools that I distro today will actually come with it by default. Yes.
So, Audit D, and I saw the slide up there, and I've messed with Audit D a lot.
It's already.
Okay. The sequence numbers that come in Audit D will paint a picture of an initial inject or whatnot. I don't understand how the eBPF is different from Audit D. I know Audit D is very convoluted to look at, and it's hard to understand, but are you guys just kind of pulling that all together and producing it out? Because you say you're no longer using Audit D anymore.
Right, so let me clarify that statement. I am by no means telling you not to collect Audit D data. Please leave that logging on. That would be bananas if you turn it off. But let me clarify. So what I'm talking about is as the event is actually occurring, typically the OS at a certain layer will, after the event has already occurred, will create the log, correct? This is going to be in stream. So as I actually do anything on this system, inject into notepad.exe, right? It is going to immediately create a sublog into Elastic, that eBPF. I'm not saying it won't be logged into audit log. Yeah. I'm just saying it's a lot easier to look through audit log.
So there's polar opposites between like the really popular Splunk and Elastic, and the complaint is sort of by people who are used to Splunk when you try to introduce them to Elastic is, oh, this isn't even a SIEM, this is a log management tool, and I don't have any features. Is Elastic looking for any kind of way to like bridge the gap, like default dashboards and stuff like that?
So inside of security, there are a ton of different use cases for dashboards, right? And by default, you could say, hey, look, you should bring up anytime a user uses FTP or whatever, right? There's a million use cases. One of the benefits I'll say when it comes to Elastic is that there are enough people that by now that have used it to where there are plenty of GitHubs for you to go out and grab formats for dashboards. I can't see saying that Elastic is behind in that only because so much of the community is already using it for security. But you're right, out of the box, it is an empty Elastic instance, right? It's on you to configure it. That is by default because there's a million use cases for Elastic. It's a data science company, right? Yeah. Are there any other questions? Well, again, thank you very much. Thank you for bearing with me as I struggled through it. Thank you.